So sometimes we have to find what's called a unit vector, and unit vectors, of course, are vectors whose magnitude is 1. But a unit vector has the same direction as a particular vector. So, for example, you have this vector here, and let's say it has a magnitude of 3. Well, I'm going to find a unit vector would be the exact same direction. The only difference is that it would be, it would have a unit of 1. So it would be a third of that. So if this one were u, then my magnitude would be 1. Same direction, but just squashed down to a magnitude of 1. Okay, so all we do is take our vector and divide it by the magnitude. That's it. So if the vector, for example, this is my vector here in example number 3, find a unit vector in the direction of 5, negative 12. So in order for me to find, and I'll call this one v, it's just a little bit easier. So when I am finding the magnitude of v here, remember I take the 5 and I square it. I take the negative 12 and I square it. And some of you may recognize this is a Pythagorean triple. So what's going to be my result? 25 plus 144, square root. 169, radical, so 13 is my magnitude. So the rule says if I want to find the unit vector in the direction of 5, negative 12, all I have to do is take my 13 and divide that into each component. So let me call u for unit vector is going to be 5 over 13 and negative 12 over 13. And that's it. In other words, we divide this puppy by 13, each component, and we're done. Our unit vector here. Doesn't always have to have fractions, but in this case it does. The next part is not just about any old unit vector, but our very, very, very special unit vectors. There are 2 of them. Notice that this one talks about horizontal, and this guy here is talking about vertical because it only has the y component there. So these guys are called my standard unit vectors, and they're represented here, as you can see. This is my, and they call that my I. You have to so watch out because I, in one context, means the square root of 1. But I, and I'm trying to bolden it, in this context means my horizontal vector, unit vector. So just beware of the context. This one here is j, and it is my vertical component, or my vertical unit. So now that we've defined I and j, and they're denoted as follows here, we can take any old vector and we can split it up. Notice that the v1 is going to attach itself to the horizontal unit vector, the I. And notice that v2 is going to attach itself to the vertical unit vector, and we call that j. All right, example número 4 on this Cinco de Mayo. Let u be a vector with initial point negative 2, 1, 2, and terminal point 4, negative 6. Write u as a linear combination of I and j. So, first we want to be able to rewrite u in its proper form, like this. Remember, you take your components here, and we're going to subtract them. And we do the exact same with the y values. Negative 6 minus 2.
That's the magnitude, right?
No, we just found the component form of the vector.
Okay.
And so this one here becomes 5, And this one here is -8. And that is component form. But that's not what it asked me to do. It asked me to write it as a linear combination of I and j. So I need to split up. This attaches itself to I, and this puppy attaches itself to j, and that's it. Now notice the linear combination is going to be a sum. See that there? It's a sum. So it's not like it's a point with a comma and brackets of some sort.
Wait, what is the 5, 8, -8?
So we're not quite done.
I know,
So
what is that called? Like when you
this one here is just called component form. So I just bring the 5 down with the I. I'm going to boldface it. And then plus, bring the let me change that to minus. Bring down the minus ochito loquito with the J, and I'm going to thickify that just a little bit, like so. Atut, I'm done, no mas. So component form is what we did yesterday, and this here is called linear combination of I and J, or using unit vector form. So notice that I have example number 5 is in a particular form already. It's in my unit form and unit form here. So I can do vector operations, scalar, multiply by 2, multiply by -3, and add or subtract, etc., just by considering the individual components. So we'll show each step. U is this. So double that to get 2I minus j there. And I'm going to subtract 3 of these. Now, this is effectively distributive property. You send it out and combine your like terms. So I get 4I minus 2j plus 3I minus 24j. And now these two combine here. Remember, these are not complex numbers. That's the unit vector component. And the other one is minus 26j.
You're factoring out the numbers?
So here I combined like terms, in other words, like vector pieces. Down here I distributed, and here I just substituted.